So in today's video, we're going to see how multiplying polynomials works. The first thing we need to check out before we actually talk about multiplying polynomials is going to be properties of exponents, right? So there are 8 main properties of exponents, but the most common ones are this one up here. So I'm gonna mark it there, and this one over here, and this one over here. I believe those 3 are kind of the most important ones, and the others are very specific to each particular case, right? Okay, so we're gonna begin. Okay, so I'm gonna remove these dots. Okay, so the first one over here. So it states that x to the m power times x to the n power is going to be equal to x to the m plus n power. So as you can see, they have the same base, and the exponents, when we have the same base, the exponents are just going to be added to each other. Okay, so in this example, we have a to the third power times a to the second power. Since we have the same base, we just add the exponents, so we get a to the 3 plus 2 power, or a to the 5th power. Okay, now the second one that is right here. Now this one is it's the opposite of the last one. So instead of multiplying, we actually divide. So it's x to the m power over x to the n power, or divided by x to the n power, which is going to be equal to x raised to the m minus n power, when x is not 0. Okay, so this one is another very common one, and mainly because it's the opposite of the first rule, rule slash property of exponents. So that's very used as well. And in this example, we can see d to the 5th power over d to the 1st power. So since they're dividing and they have the same base, we just do d to the 5 minus 1 power, or d to the 4th power. Okay, now this third one, it's only used in very specific occasions, but it's important to know. Okay, so it states that any number raised to the 0 power is equal to 1, and this is very specific to some cases, but it's important to know just if you encounter a problem that has this sort of exponent in it. Okay, now this one is a very common one as well, which states that x to the m raised to the n power is actually going to be equal to x to the m n power, or m times n power. Okay, so this is actually called power of powers. So what we do is basically we just multiply both exponents, right? And we can see that makes sense in this example down here. Okay, so it states that a to the 3rd power raised to the 2nd power is going to be equal to a to the 3 times 2 power, or it is equal to a to the 6th power. Okay, now the next rule is kind of similar. The next 2 rules are going to be similar to the power of powers one, except there are some minor differences, mainly because we have to use distributive property. Okay, so yeah, now for this first one, we have x to the m power divided by y to the n power, all of that raised to the p power, is going to be equal to x to the m p power divided by y to the n p power. So we can see that the exponent that is raising all of the division process, or the fraction, is actually being distributed to both the numerator and the denominator. So that's very important to keep in mind. So it kind of works like the distributive property. Okay, now in the example, we can see a to the 2nd power divided by b to the 3rd power, all that raised to the 3rd power. Okay, so that is going to be equal to 2 times 3, that's 6, and 3 times 3, that's going to be 9. So our final answer is a to the 6th power divided or over b to the 9th power. Okay, now this next rule is also very similar. It's actually the same rule as the power of powers rule over here, except for the fact that we have multiple exponents, and we do the same thing here as we did in the last time. So we distribute the exponent that is raising all of the expression. So now we have x to the m power and y to the n power, all of that raised to the p power. So now we have x to the mp power and y to the np power. Okay, so we can see that this distributive property actually being used in the example below. So it says x to the 5th power and times y to the 3rd power, all of that raised to the 2nd power, is going to be equal to x to the 5 times 2 power and times y to the 3 times 2 power. So it's actually, the answer is going to be x to the 10th power times y to the 6th power, or x to the 10th and y to the 6th. Okay, now this one down here, it says that x to the negative n power is going to be equal to 1 over, or 1 divided by x to the positive n power. So this one is very useful when we have negative exponents, which, as we know from the introduction to polynomials video, that we cannot have negative exponents when we are multiplying polynomials or making any operation that involves polynomials, right? So we basically flip it so that the exponent becomes a negative exponent. We can see this in the example below that says a to the 2nd power is equal to 1 divided by a to the positive 2nd power. Okay, so that's very useful when you have negative exponents and you know what to do with them. Just go back to this property and remember that you just have to flip it. Okay, and finally, this last one over here states that x divided by y, all of that raised to the negative n power, is going to be equal to y over x, or divided by x, all of that raised to the positive n power. So as you can see, when you have an exponent, a negative exponent that is being raising a fraction, what you can do is just flip the fraction, and that way you can get a positive exponent. And we can see this in the example below, which states that x over y raised to the 8th power is going to be equal to y over x. Sorry, I got confused. So in the example it says x over y raised to the negative 8th power is going to be equal to y over x to the 8th power. And this property only applies when x and y are not 0. So that was it for for the properties of exponents, and now we are going to talk. Now we're going to begin talking about actual multiplication of polynomials. Okay, so in this video now we're gonna talk about multiplying polynomials. Now that we know about now that we have learned about the properties of exponents, in this video we will be talking about multiplying polynomials in different ways. Okay, so first we're going to begin with a monomial by a monomial, or a monomial times a monomial. Okay, so we have this case here that states that x to the 5th power is equal to x times x times x times x times x. Okay, and following the first rule of exponents, we know that when you have two numbers being multiplied, two variables being multiplied, they have the same base, and that if they have the same base, you can simply just add the exponents, right? So we get x to the third power times x to the second power is going to be equal to x times x times x times x times x, or x to the fifth power. So based on this, we know that x to the third power times x to the second power is equal to x to the 3 plus 2 power, or x to the fifth power. Okay, and this is one of, if not the most important rule that when we're multiplying exponents, because it's used in basically every exercise involving this. Only very specific cases don't have it, but because they include other properties to apply. Okay, now we have two types of exercises that I want to talk about. Okay, the first one is multiplying exponential expressions. Okay, so we are going to begin this exercise over here. Okay, so this exercise says -5 to -5a to the second power b times 3ab to the fifth power. Okay, now what we have to do is that we have to kind of like separate or break down each one of the monomials, right? We have to like split them into categories. So now we are going to multiply. First, we're going to start by the coefficient. So -5 times 3. Okay, and then we put we multiply that to the a. Okay, so to the like terms that have a. Okay, so after we find like terms, we see that we have a2 plus 1, because remember that this over here is a exponent of 1. Okay, so that is very important to keep in mind. And finally, we multiply it by b, and here it says 1 plus 5. Okay, so that's going to be kind of the way you would approach an exercise. You kind of separate each individual part, and then you multiply like terms, if you can say it like that. Okay, and after that we simply just multiply. So -5 times 3 is equal to -15. A to the first to the 2 plus 1 power is a to the third power, and b to the sixth power, and that would be our answer for this exercise. Okay, now moving on to our next exercise, which is talking about simplifying powers of exponential expressions. Okay, so the first thing we are gonna want to do is that we want to distribute this exponent over here thanks to our order of operations. So we have PEMDAS, right? So there are the parentheses, but because they are multiplying, so that's actually multiplication. So the first thing in this exercise to do is the exponent. So now we have to distribute that exponent. Okay, so we have this one that isn't being affected by the exponent, so we just leave it like that. And then we have this big one that affects each and every one. So we have 3 raised to the third power, and we just kind of distribute it properly. Okay, so now a to the fifth times 3, because when you have power of powers, you multiply the exponents. And finally you have b to the third power. Okay, now that we have that, we can simply multiply. Okay, so you have 3a to the second power and b to the second power, all that times 3 to the third power is going to be 27, right? Yeah, it's going to be 27. 5 times 3 is going to be 15, and b to the third power. And now we can just multiply as if we were talking about multiplying exponential expressions. Okay, so a lot of working with polynomials, sorry, is kind of slowly simplifying the expression, so that eventually we just have to multiply or add each like terms. So it basically like making it easier and easier every step we go. So kind of the first couple of steps can be a bit difficult, but as you go through, they get easier through time. Okay, so now that we have the same exercise, we're just going to multiply as we learned before. So we multiply the coefficients, 3 times 27, and the a's, the variable a, so a2 plus 15, and a b squared plus 3. Okay, so 3 times 27 is 81, and 2 plus 15 is 17, and finally 2 plus 3 is 5. So that is going to be our answer for that problem. And that was basically it for multiplying a monomial by a monomial. And that is a very simple process that we will be kind of applying in other types of exercises, such as polynomials by monomials, or even polynomials by polynomials, because as I mentioned before, it's kind of just simplifying it so that each time we get a simpler operation. Okay, so now we're going to move on to multiplying a polynomial by a monomial.